I am Mr. Ish and I welcome you this morning to this video, Arithmetic Sequences. Not too long ago we looked at the general concept behind arithmetic and geometric sequences. I'll include a tag to that video in the information for this. But in this one we're focusing particularly on arithmetic sequences with an examination of these two items. If you're given a sequence, you have to find a specific term. We can call that a, n, subscript n, and we have to find the sum of that arithmetic sequence. You can look at it in terms of s, sum with a subscript. For instance, if you have a sequence which looks like this, you know this right here is an easy sequence. Everything seems to be increasing here by 2. There's a common difference here. A common difference, we can say d is equal to 2 because each number, successive number, is 2 above the one before it. If I were to tell you find me the 15th term, how would you do it? There's a formula for doing that. In this particular case it's easy because you can easily extrapolate it. But what if I told you to find me the 150th term? Then you have to do too much manual counting to determine that. Or you can use a formula. If I told you to find me the sum of all of those 150 numbers, each being differing from the previous by 2, how would you do that? There's a specific formula for that, and that right there is the essence of this particular video. We're going to learn all of that because it's relevant. We have to know that. Just a quick rehash. If you have a specific number you're interested in, that's a and then n. The number right before is a n minus 1. The one right before, because it's a number right previous to the one you're looking at. D here represents your common difference. That is how much does each number differ from the one previous or from the one after. If you have all of these items here in mind, then to find the nth term or the term you're interested in, the formula is this: a1 plus n minus 1 d. And n over here represents the number of items in your count, number of items. And that formula will help you determine whatever number it is in that sequence of arithmetic numbers that you're looking at. It's not a difficult formula here at all to comprehend. Let's go back to this item I had at the very beginning: 1, 3, 5, 7, 9, and I want to find the 150th number. This right here is a. In this arithmetic sequence, I want to find the 150th number. Well, I know I'm really looking at a and then n, but here n represents 150. I know the first term, it's 1, and I know their total terms in this sequence are right here, 150, right here, because I'm focusing on 150. And then I know the common difference here is 2. Each number is differing from the other by 2 units. So you just run everything here through that formula. You will do 150 minus 1, you multiply that by 2, and you'll add that first number, 299. As you go through this progression, your number, the 150th number, will be 299, and you could manually count it if you want to, but this answer here would be right. So this right here is helping us determine how you go about determining that, and we'll put this formula right here. A(n) is always equal to the first number plus n minus 1, the total numbers, less 1 times the common difference. Now the next question we want to focus in on is what was the sum of those 150 numbers in this particular arithmetic sequence. There's a formula for that as well. The formula is not too hard to remember. It's going to be this: n over 2 a1 plus an. But for this you have to determine this an first. N, the total number of items in your sequence, divided by 2 multiplied by the sum of the first and that last. We already determined what that last one was. The 150th term turned out to be 299. So therefore the sum of all of these 150 numbers going from 1 all the way to 299 would be this. You have 150 items in this sequence times 1 plus 299, and this will give you the sum of those 150 numbers where each number differs from the previous by 2 units. You'll do 1 plus 299 divided by 2 times 150, and the sum of those numbers will be 22,500, and it should be right. It wouldn't seem that it's true, but it is. You'll do 1 plus 3 plus 5 plus 7 plus 9 plus 11 plus 13. Initially your sum won't increase as much, but as you start getting into those double digits, then from 100 you're going 100 plus 103 plus 105. Those triple digit numbers, they all will add up relatively fast, and you will have a total sum of those 150 numbers to be 22,500. So we can include that formula over here. But remember, this formula could only have been done if you knew this. You would have had to calculate that first. and then you would take that item into the sum formula. So now what remains is for us to look at two interesting questions with regards to these arithmetic sequences. So what I will do in this first question, I'll purposely pick an easy one because I want to test it out and make sure you are confident that these formulas are good. If our sequence is this 4, 9, and then this, we have to find the sixth term and we have to find the sum of those six terms. You know, it's not too difficult over here. Our first item here is 4. Our common difference appears to be an minus 1. We have an and then we have the one before minus these two. You have a common difference of 5. Let's look at right here the sixth term. A6 is equal to the first term 4 plus the total number of items. There's 6 over here because we're looking here at S6, 6, right? 6 minus 1 times the common difference 5. Everything just falls right here into the sequence. You have 6 minus 1 times 5 plus 4, you have 29, and that's our answer. The sixth term is 29, and it will indeed prove to be true because you have 4, then you have 9, then the 5 units after that, because each is differing by 5. You'll have 14, then you'll have 19. After this, you'll have 24 and then 29, and there it is. 1, 2, 3, 4, 5, 6. The sixth term is 29. Now let's find the sum of these six terms, and the formula is right over here. N divided by 2. N over here is 6 divided by 2, the first term which was 4 and the last term 29, and you can do this 4 plus 29 divided by 2 times 6, 99, and that answer here should be right. And we can manually check this, which is why I purposely picked an easy sequence. Just add those numbers right there. 4 plus 9 plus 14 plus 19 plus 24 plus 29, and we have 99. So we know that these formulas are good, so you should be confident in these formulas. These formulas are right. This formula right here, the nth term and the sum of the sequence in that arithmetic sequence, these formulas are good. For our second and this last question of this video, let's look at a sequence which is this. We have 5, we have 10, we have 15, and you know what this sequence is. We have to find the 20th term, an is equal to 20, and we have to find the sum of these 20 terms. What are they? Well, look right here. We're looking at the 20th term. We have to find that specifically. We know the first term is 5. And how many terms do we have? Well, this right here is our n value. Each item is differing from the next with a common difference of 5. Our first term is a1, which is 5, and then we have 20 terms, 20 minus 1 times that common difference 5, and that gives you everything you need for this formula. You have 20 minus 1, which is a 19, multiply that by 5, add 5, and you will have your 20th term 100, which makes sense. If each item is starting from, if the sequence is starting from 5 and you're differing by 5, 20 times 5 gives you that 100. But you can rely here on the formula and it's just as good. And now for S20, what is the sum of these 20 terms in this arithmetic sequence? You have the formula over here, n over 2, but it's 20 over 2. You have the first term and then you have the last term. You sum them, you multiply them by that. You'll have 5 plus 100, which is 105 times 10. And you'll have 1050, and it'll be right. The answer here will certainly be right. Both of these are good. So remember, for an arithmetic sequence, you're looking at a sequence of numbers where there is a common difference. There's the same common difference between each number and the one right after it, or the one right before it. That common difference is coming right here into this formula to help you. Given that you know the first term, you can find any term in that sequence. Then using that, you can bring this in this formula and determine the sum of those sequence of those numbers in entirety as you want. You'll have everything you need coming here from this formula and from the sequence to determine that sum of that sequence. And all of this here is with regard specifically to arithmetic sequences. For geometric sequences where you have a common ratio between each term, the set of formulas are slightly different. This right here pertains everything to arithmetic sequence. It's all relevant information and you should know this. High school maths and standardized exams, this is relevant material. Thank you for watching. Have a great day. Bye.